Nuclear explosions have captivated our imagination for decades, often depicted in movies and documentaries as cataclysmic events. But have you ever wondered about the science behind these immense bursts of energy? In this article, we will delve into the fascinating world of nuclear explosions and explore the underlying principles that make them possible. Understanding nuclear fission. To comprehend nuclear explosions, we must first grasp the concept of nuclear fission. Nuclear fission is the process of splitting an atomic nucleus into two or more smaller nuclei, releasing an enormous amount of energy in the process. The most commonly used fuel in nuclear explosions is uranium-235 or plutonium-239, both capable of sustaining a chain reaction. The role of neutrons. The initiation of a nuclear explosion relies on the presence of neutrons. When a neutron collides with a fissile nucleus, such as uranium-235, it becomes unstable and undergoes fission, splitting into two smaller nuclei and releasing additional neutrons. These newly released neutrons can, in turn, collide with other fissile nuclei, leading to a self-sustaining chain reaction. Critical mass and control. Maintaining a controlled chain reaction is crucial. To achieve this, a minimum amount of fissile material known as the critical mass is required. If the mass falls below this threshold, the chain reaction cannot be sustained. Conversely, if the mass exceeds the critical point, an uncontrolled explosion can occur. Controlling the rate of neutron production and absorption is essential to prevent an unintended detonation. Explosive energy release. During nuclear fission, a small fraction of the mass of the uranium or plutonium is converted into an immense amount of energy, following Einstein's famous equation, E=mc². This equation states that energy, E, is equal to the mass, m, multiplied by the speed of light, c². The enormous energy release during a nuclear explosion is a result of this conversion, with only a tiny fraction of the fissile material actually being consumed. The role of an implosion. Nuclear explosions can be triggered by an implosion mechanism. In this process, a conventional high explosive, such as TNT, is used to compress the fissile material into a smaller and denser state. This compression increases the density and enhances the probability of a successful chain reaction. When the explosive force is applied uniformly from all directions, the fissile material collapses, leading to a rapid and efficient release of energy. Differences between atomic and thermonuclear explosions. It's important to differentiate between atomic and thermonuclear explosions. Atomic explosions rely on nuclear fission alone, while thermonuclear explosions involve an additional stage called nuclear fusion. In thermonuclear devices, a primary fission explosion triggers a secondary fusion reaction, which releases even greater amounts of energy. The fusion reaction occurs when light atomic nuclei, such as isotopes of hydrogen, combine to form heavier elements, accompanied by a colossal release of energy. Nuclear explosions are the result of harnessing the immense power released during nuclear fission or fusion reactions. Understanding the science behind these events allows us to appreciate the complexity and potential danger they pose. While their immense power has been harnessed for both destructive and constructive purposes, the importance of responsible handling and strict international regulations cannot be overstated. As we continue to explore the mysteries of the atomic world, it is crucial to utilize nuclear energy for peaceful means, advancing scientific knowledge and benefiting humanity as a whole.